So I will discuss the doubts today related to November 2021 paper. In a question, X is a pink solid and Y is a blue solid. When X is heated, the water is produced and a solid turn blue, and when water is added to Y, the solid turn pink. What is X and Y? So this give an idea because as they're changing a color, this give an idea these are the hydrated salts. So when we have copper sulfate, which is anhydrous without water crystallization, what is the color of anhydrous copper sulfate? It is white in color. When a water is added, what it will turn? It will turn into hydrated copper sulfate. And what is the color of hydrated copper sulfate? That's blue. Same thing if we have cobalt chloride is there. We have a cobalt chloride and a water is added, water of crystallization. Anhydrous cobalt 2 chloride is there. That is blue in color without the water of crystallization. But when water of crystallization is added, what it will turn? It will turn into pink. These are the hydrated salts, and their reactions are reversible because the anhydrous can turn into hydrated, or it can be other way around. And when anhydrous turn into hydrated, it will release energy, but to turn hydrated into anhydrous, we have to supply energy. So X is a pink solid, where Y is a blue solid. And they mention X is heated. So we heat X and water is produced plus it turned into blue. So the pink turned into blue. So what this give an idea? This give an idea that X is a pink solid. So this is X and it turned into blue. So it means it turned into anhydrous cobalt chloride because anhydrous cobalt chloride is blue in color. So when X is heated, like when we supply heat energy to this one, the water of crystallization will be lost and it will turn into blue. So when water is added to Y, when we add water to Y, the solid turned pink. Like it turned back into pink. So what is X and what is Y? So what is X? X is the hydrated cobalt chloride and Y is anhydrous cobalt chloride. That's why B is the right answer. Why we did not select for a copper? Because if it was a copper and when we are supplying the heat energy, it should be blue. Because initially it should be blue and then it turned into a white if we supply the heat energy and break down hydrated copper sulfate into anhydrous copper sulfate. Is it clear this one? In this question, iron 2 chloride solution react with a chlorine. The equation is there. Which statements about this reaction are correct? So first because oxidation and reductions are, so iron plus 2 iron are reduced to iron plus 3. Actually, it's wrong. It's because this is iron plus 2 is there and this is iron plus 3. So what it shows it is oxidized, not reduced. That's why this statement is not correct. And for chlorine, because chlorine is 0 and then it become -1. -3 is for total, but -1 for each. When we check what is the change in oxidation number, we check for individual, each of them. So for each chlorine, it is -1. So when 0 become -1, what we call this change? We call that as a reduction. And if the change is reduction, the substance is acting like an oxidizing agent. And here iron 2 turned into iron 3. So this change is oxidation. And if it's an oxidation, the substance is acting like a reducing agent. So iron 2 turned into iron 3 is not correct. Then chlorine act as a reducing agent. How chlorine is not acting as a reducing agent, chlorine is acting like an oxidizing agent. Why oxidizing agent? Because chlorine is 0 here and the chlorine charge is -1. So when 0 become -1, this changes reduction or the substance is oxidizing agent, not reducing agent. And here iron plus 2 is there because chlorine is this 2 is representing the oxidation number of iron. And here this iron is +3. So if a +2 turn into +3, like there's the increase in oxidation number. So this change is known as oxidation, or the substance is a reducing agent. So chlorine is not acting like a reducing agent, it is acting like an oxidizing agent. That's why 1 and 2 are wrong. So iron 2 chloride, when you have FeCl2, each chlorine is -1, so 2 chlorine will be -2, so iron should be +2. And in iron 3 chloride, FeCl3, each chlorine is -1, so 3 chloride will be -3. So iron should be +3 because the overall compound should be neutral. So when we check the change in oxidation number, the +2 become +3. So if the +2 become +3, this is an increase in oxidation number. So we call that change as oxidation, or a substance will be a reducing agent. And iron 2 ion each lose an electron. That is correct, because if +2 is becoming +3, so +2 become +3 means it should lose one electron. Like that's why the charge increases by 1. If it was losing 2 electrons, then it will be +4. It will change from +2 to +4. If it was losing 2 electrons, then the iron 2 will turn into iron 4 if it is losing 2 electrons. If it was losing 3 electrons, then iron 2 will turn into iron 5. So iron 2 ions loses an electron. That is correct. And chlorine molecules are reduced to form a chloride ion. That is also correct. That's why D is the right answer. Option 3 and 4 are statements are correct. Is it clear, this one? So whenever a molecule is there and you want to write the valency for any molecule, like example, if I say what is the oxidation number of potassium in potassium chloride. So chlorine is group 7 -1, so potassium should be +1. And overall charge on the molecule should be 0. But if it was potassium oxide like K2O, so each oxygen is -2, so each potassium is +1, but total will be +2 because the overall molecule should be neutral. As it's a molecule, no charge should be there. But when we check whether it is oxidation or reduction, we check for individual. Like when we were checking for chlorine here, this chlorine was 0 and this chlorine was -1. Why we even though total is -3, but we always check for individual, like each atom. So 0 become -1 is a reduction. The noble gases are in group 8 of a periodic table. Which statement explain why noble gases are unreactive? Like why they don't react? They all have 8 electrons in the outer shell. Why this statement is not correct? Because it does not fit into helium. Helium is having 2 electrons in the outermost shell, so its outer shell is complete. So it does not fit with helium. They all have full outer shell electrons because the outer shell are complete. That's why they don't react. And that's why, because the outer shell is complete, that's why they don't form molecule. So actually statement B explains statement 4. Like because their shells are complete, because they are not reacting, that's why they don't form molecule. They always exist as monoatomic state. Like for a neon, because there are 8 electrons in the neon, so it does not have tendency to react. Reactive element can be monoatomic for group, like metals can be monoatomic element. Like when we write here, potassium is K, sodium is Na, calcium is Ca, magnesium is Mg. So for metals, we write them as, like showing the in a reaction, we write them as single atom. But for group 8, for group 8 elements, because their shells are complete, as the outer shells are complete, and these outer shells complete means they don't have a tendency to form a molecule, so they will remain as monoatomic gas. And why gases are there? That is related to the intermolecular force and the type of a structure. Is it clear, this one? Which statement about the Haber process are correct? So what is the Haber process? It's a manufacture of ammonia when nitrogen, one molecule of a nitrogen combined with three molecules of hydrogen to give off ammonia. And the forward reaction is exothermic. So reactants have high energy and the product will have low energy. One of the raw material is extracted from a liquid by fraction distillation. That's true that they're talking about nitrogen. Nitrogen is extracted by the fraction distillation of liquid air. One of the raw material is produced by reacting steam with methane. That's also correct. That's how we produce a hydrogen is there. The hydrogen is produced by when steam reacted with methane. This is a way to produce a hydrogen. But about the third one, the catalyst for the Haber process is vanadium pentoxide. That's wrong because vanadium pentoxide is not a catalyst for a Haber process. It is actually a catalyst for a contact process, like manufacture of sulfuric acid. Here we use iron as a catalyst. So statement 1 is correct, 2 is correct because 2 give hydrogen. So that's why B is the right answer. Is it clear? No, you don't have to learn this reaction, steam reaction with methane. You don't have to learn that. As an information now, and according to the syllabus outline, you don't have to even learn how it can be manufactured. So just the reaction conditions are important. Reaction is reversible, the application. These are the things you should. Lime, which is calcium oxide, is used to treat the waste of a water. Lime is what? It's a metal oxide. Look, when we have oxides, oxide means when the element combined with oxygen, it will form oxide. Oxide can be metal oxide, and oxide can be a non-metal oxide. When a non-metal combined with oxygen, it will form a non-metal oxide. Metal oxides are divided into two categories. One is known as the basic oxide. Basic oxide can react with acid only. And another one is amphoteric oxide, can react with both acid and alkane. Non-metal oxides can be acidic oxide. They can react with only base. And it can be neutral oxide, cannot react with acid nor with base. So carbon monoxide, and remember the examples of aluminum and zinc oxide as amphoteric. Rest all the basic oxide, you will categorize them as metal basic, like rest all the metal oxide, you will categorize them as a basic oxide. So we have calcium oxide. Calcium oxide is a metal oxide. So when metal oxide is there, if it does not belongs to aluminum or zinc, so it means it should be a basic oxide. And what is the characteristic of a basic oxide? The basic oxide can react with acid only. So there is no reaction with base, it's only react with. So ammonia is a base, it won't react. Sodium chloride is a salt. So there will be no reaction mixing. Again, sodium hydroxide is a base, so there will be no reaction. So we are left with sulfuric acid. Is it clear, this one? Why sulfuric acid is reacting with calcium oxide or a metal oxide, but not the others? The term, yeah, it's you should know these terms when they use the term lime. Lime means calcium oxide. When they use the term slag lime, it means calcium hydroxide, but in a solid state. And when they use the term lime water, this is also calcium hydroxide, but in aqueous state. And the limestone is there, that is calcium carbon, CaCO2. The next alkane react with a chlorine to form a chloroalkane. Which statement about a reaction of alkane with chlorine is correct? So alkane is there reacting with chlorine. So one chlorine enter, one hydrogen leaves, so it will form CH3Cl plus HCl will be there with the product. First, alkenes react with chlorine by addition. No, this is not an addition reaction. This is a substitution reaction. The gaseous product turned the red litmus blue. No, it will be opposite. It will turn blue litmus red. Why? Because the gaseous product is HCl here. HCl, when a damn blue litmus is there, because it is an acidic, so blue litmus will turn into red. So the gaseous product will not turn red litmus blue, it will turn blue litmus red because that is HCl. Then the chlorine atom in a chloromethane are covalently bonded. That's true because they are non-metal. They all have a covalent bond. And the general formula for chloroalkane is CnH2nCl. That's not correct. The general formula will be CnH. As you can see, like when we write here CH3Cl, or it might produce C2H5Cl, or it might produce C3H7Cl. So number of the hydrogen are twice plus one, twice plus one, twice plus one. So the general formula will be CnH2n plus 1 Cl. Is it clear? Discussion? An alkene molecule with a molecular formula of C8 and H18 undergo a cracking. The equation for is shown for a cracking. The substance R contains 2 carbon atoms per molecule. Like there are 2 carbon atoms in one molecule. Yeah, that is like C2, and H can be, and that decolorizes the bromine, so it is an alkene. What is substance Q? So look here, we have C8, H18 is there. So 2 carbon atom per molecule. So C2 is there. So how many hydrogen? Because it's an alkene. So the number of hydrogen should be twice. And there are 2. So we put 2 here. Why? Because 2 molecules as shown. Now, how many carbon we are left with? Because out of 8, 2 multiplied 4 are used here. So we are left with 4. And how many hydrogen we are left with? 2 multiplied by 4 is 8. So out of 18, if 8 are used here, so we are left with 10. So C4, H10, what is Q? Q is actually a butane. So A should be the right answer. Is it clear, this one? The term per molecule means like if we have one molecule of R, it contains 2 atoms. Like it means that this molecule contains 2 carbon atoms. So if there are 2 carbon atoms, the hydrogen should be double. Why double? Because it decolorizes the bromine, so it means R is an alkene. If the same question was there and they say R has 3 carbon atoms per molecule, so what will the formula for this? So then it will be C3 and H6. Like how many atoms in one molecule are there? That means number of carbon atoms per molecule. In one molecule, how many carbon atoms? So 2 carbon atom per molecule means if there was one molecule, it contained 2. So because there are 2 molecules, they contain total 4. For an equation, the mole and the molecules are same here. Like when you're writing, because one equation is actually in terms of simplest ratio of the mole or simplest ratio of the molecule. The equation, because what it shows, this equation shows that if I have one molecule of which contains 8 carbon atoms and 18 hydrogen atom, when we crack, it gives us 2 molecules of the carbon atom which is having like 2 carbon atom per molecule, and another one will be C4NH10. So the equations are in terms of molecules as well. Like one molecule of C8H18 gives one molecule of C4H10, and it gives 2 molecules of C2H4. That's why in this case, the molecule here represent the number of the mole. But calculation point of view, 1 mole contains 6.02 exponent 23 molecules. This is the same question I discussed earlier. Group 7 element shows a trend in their physical properties, chlorine, bromine, and iodine. Which row show the missing heading from the properties in the table? First, if you check these melting point and a boiling point. So it is obvious, one thing is obvious, that first we'll have a melting point and then we'll have a boiling point, and melting point should be lower than the boiling point. So what X is representing, X is representing it cannot be density, because density cannot be negative. So that is totally wrong. So either it can be a melting point or boiling point. But when you check the two values, one is minus 101, another one is minus 34. So what it shows? It shows that first is a melting point and second is boiling. Because the boiling point should be higher than the melting point. Boiling point cannot be lower than the melting. Because first you have solid, then liquid, or then the gas. So what column X is representing? It is representing a melting point. Y is representing a boiling point. And both increases as we go down the group. And what Z is representing? Z is representing their densities. And density also increases because first two are gases, then a liquid, and then solid. So melting point, boiling point, and density. So B should be the right answer. Is it clear, this one? Melting point increase due to the, yeah, that's true. Melting and boiling point increase due to strong attractive force between the molecules. These type of forces between the molecules are known as van der Waals force. These are forces between molecule. When we have a molecules are there, the forces between the molecules, which is called a van der Waals force, and that you will learn in A levels, not in O levels, that van der Waals force depends on the number of electrons in each molecule. So as the number of electron in each molecule increases, the van der Waals forces increase. That's why as we go down the group, the boiling point increase for group 7. Yeah, van der Waals forces or intermolecular force, it's the same thing. But it depends on the number of electron and other factors that not now. You just have to, in IGCSE O levels, you just have to learn the trend rather than a reason here. But in A levels, you will learn a reason for that as well, like why it happened like this. In the question, the structure of 4 organic molecules are there. How many different homologous series are there? So this is halogen alkane, one series. This one is C double bonded with OH. It is a carboxylic acid, one series. There is OH, so this is alcohol. This one is also OH, so this is also alcohol. So how many different series are represented here by these molecules? Because these are the same OH, so it shows that both belongs to alcohol. Is it clear? Why we did not? The first one is halogen alkane. Halogen alkane means like there is a carbon chain and there is a halogen, so we call them as a halogen alkane. Or you can also say alkyl halides. Alkyl halide or halogenoalkane, it's the same thing. Like there is a halogen and there is a carbon chain, with a single bond, which is known as an alkyl group. Like it might be CH3, might be C2H4, might be C3H6. Sorry, C3H7 will be there. So when carbon chain is attached to these halogens, it's called halogenoalkane, or it's also known as alkyl halide. When this is there, it's a carboxylic acid, and OH is there, that is alcohol. How many homologous series are there in total? There are many homologous series. You can even in organic chemistry, you just studied the basic of organic chemistry. But there are many homologous. Even benzene rings are there, and then their series of homologous series. So it's many homologous series are there. But we name them with chloro first. Yeah, we say chloromethane, chloroethane. That's why I said it is halogenoalkane or alkyl halide. Is it clear, this one?